Hello everybody. In this video, we are going to talk about trigonometric ratios of allied angles. So first we'll talk about sign convention and all those things. Let's start with it. So unit circle and sign convention. For example, we have got the coordinate axis over here, the x-axis, y-axis and the origin. And we take a unit circle over here, taking origin as the center. Unit circle means the radius of this circle is 1 unit, right? And then we take any general angle theta over here. Suppose any general angle theta over here. And suppose the coordinates of this point is x comma y. Correct? So if you draw perpendicular over here, we can say that this is x units and this is y units. You can think the other way around as well, that we are taking a right angle triangle where this is x units and this is y units. So the coordinates of this point are x comma y. You can think like this as well. So over here, and you see the hypotenuse is of 1 unit length because it's a unit circle. So over here, if you will find sine theta, what is that? Sine theta is perpendicular upon hypotenuse. So that is equal to y units. In the same manner, if you find cos theta, what is that? That is base upon hypotenuse x units. You see this. So what does it mean? That if you take any point on this unit circle, suppose you take something like this. So an example I'm taking, the x coordinate of this point will represent the cos theta of this angle, right? X coordinate will represent cos theta and y coordinate will represent sine theta with respect to that angle. So using this thing, we can understand one thing. See over here. See, if it's a unit circle, the coordinates of this point are 1, 0. For this point, it is 0, 1. For this point, it is minus 1, 0. And for this point, it is 0, minus 1. Now over here, what are the respective angles? You see this? You start from this point and then you are rotating in the anti-clockwise direction. You know that when you are rotating in the anti-clockwise direction, you get positive angle, and when you rotate in the clockwise direction like this, you get negative angle. So from this, if you are rotating up till this, I will say that this angle is 90 degrees, right? And corresponding x coordinate is cos of that angle and corresponding y coordinate is sine of that angle. Using this logic over here. So can I not say over here that sine 90 is equal to 1, the y coordinate, right? And cos 90 is equal to 0. Using this logic, the x coordinate over here. And then if you keep on rotating, you get what angle? 180 degrees. So at this point, if I go, can I say sine 180 is equal to 0? And cos 180 is equal to minus 1. I hope that is clear. In the same manner, if you keep on rotating, you see this angle is what? Plus 90. You see 180 plus 90. So this angle is what? 270 degrees, right? So what will you get? Sine 270 degrees if you get over here. The corresponding y coordinate over here. So sine 270 is minus 1. And cos 270 over here is, cos 270 is the corresponding x coordinate, that is 0. Cos 270 is 0 over here. You can obviously check it once again. You see, sine theta was what? Perpendicular upon hypotenuse, so y, and cos theta was what? Base upon hypotenuse, so x. I hope it's clear. And so on, if you keep on rotating like this, you'll get 360 degree angle, right? One complete revolution in the anti-clockwise direction. So therefore, if you get sine 360 degrees, sine 360 degrees is the corresponding y coordinate 0 and cos 360 degrees is the corresponding x coordinate, that is 1, right? So I hope this logic is clear. Even if you don't remember, you can quickly think in terms of unit circle and then you can tell the values. Now there is one more thing called sign convention, right? You see, if the angle is in the first quadrant means between 0 degrees and 90 degrees. You see, this is the first quadrant, the second quadrant, I'm talking about quadrant. Correct? So if the angle is in the first quadrant, the second quadrant, this is the third quadrant, and this is the fourth quadrant. First quadrant means the angle is in between 0 and 90. Second quadrant means the angle is in between 90 degrees and 180 degrees. Third quadrant means the angle is in between 180 degrees and 270 degrees. And fourth quadrant means the angle is in between 270 and 360 degrees. Right? I hope this complete logic is clear to you, right? Now you see, if you go in the second quadrant, the same thing is there. You see the angle is over here, and you see this will be minus x upon y, something like this. Wait, now if the angle is in the first quadrant, you see x coordinate and y coordinate, they both are positive. So when the angle is in the first quadrant, all trigonometric ratios are positive. When the angle is in between 0 and 90 degrees, the value of all trigonometric ratios will be positive, because you see x and y, they both are positive. But when you are in the second quadrant, the angle is in the second quadrant, you see cos over here is the x coordinate. So over here, x coordinate is negative. So when the angle is in the second quadrant, cos will be negative. You understand that? Because in the second quadrant, cos theta will be what? Minus x. And sine theta in the second quadrant will be still y over here. So what does it mean? Cos is negative. What does it mean? Then sec will also be negative. If cos is negative, its reciprocal sec theta will be negative as well. And if sine is positive, its reciprocal cosec theta will also be positive when the angle is in the second quadrant. And then what is tan? Tan theta is what? Sine by cos, right? Sine by cos. So it is what? Minus y upon x. So that will be negative. So when tan is negative, its reciprocal cot theta will also be negative. So what does it mean? That if the angle is in the second quadrant, sine and its reciprocal cosec will be positive, and all other trigonometric ratios will be negative. The same logic will go for third quadrant and fourth quadrant as well. So there is a shortcut to remember that. There is a shortcut to remember that. ASTC rule. In short, you remember like this. There can be other short forms as well. All school to college. Other call it what? Mnemonic, I guess. Right? So all school to college, ASTC rule. It means when the angle is in the first quadrant between 0 and 90 degrees, A for all trigonometric ratios will be positive. When the angle is in the second quadrant between 90 and 180 degrees, S for sine and its reciprocal cosec will be positive, and all other trigonometric ratios will be negative. And the logic I had explained over here. And when the angle is in the third quadrant, then third quadrant means between 180 and 270 degrees, then T for tan and its reciprocal cot will be positive, and all other trigonometric ratios will be negative. And when the angle is in the fourth quadrant between 270 and 360 degrees, then C for cos and its reciprocal sec will be positive, and all other trigonometric ratios will be negative. So ASTC rule. All sugar to coffee, whatever it is, you can, I don't remember that, I just remember this, all school to college. So this is very important. Let's do a question on the basis of this property. For example, you have to find the value of this expression. This thing is multiplied to sec 100 over here. Okay, this is multiplied to sec 100. Now you remember this identity that sine square theta plus cos square theta is equal to 1. You have studied this in class 10, right? So 1 minus sine square 100 is what, guys? 1 minus sine square 100, that will be equal to cos square 100. So over here, this will give us square root of cos square 100. Correct? Multiplied by sec 100. Right? Now many students will directly say that square root of cos square 100 is equal to cos 100, which is wrong. I did explain it many times on the Infinity Learn class 9 and 10 YouTube channel, and you must also have studied that square root of x square is never equal to x, right? It is basically equal to modulus of x. The simple logic is, when you take this sign, it means they are talking about positive square root. So for example, if you have got square root of minus 2 square, so you will say minus 2, that is wrong, because this sign, if you make, they are talking about positive square root called principal square root. So therefore you have to take modulus of minus 2, and you know that is equal to 2 only, right? So therefore over here as well, it will open up like this: modulus of cos 100 multiplied by sec 100. Right? Now you have to decide whether cos 100 is positive or negative. You remember ASTC rule. Now 100 degree is in which quadrant? 100 is in the second quadrant, right? You see 90 plus 10 is 100. In the second quadrant, only S for sine and its reciprocal cosec is positive, and all other trigonometric ratios are negative. So we know over here that cos 100 is a negative value. Now you remember how to open modulus? You see modulus of x is what? It is equal to x when x is greater than equal to 0, and it is equal to minus x when x is less than 0. Equal to 0 you can put in both of them, no problem. So over here we know that cos 100 is negative. We know that it is negative. So in order to open up the modulus, we have to put an extra negative sign. So it will be minus cos 100. It will be minus cos 100 multiplied by sec 100. Now you know that cos and sec, they are reciprocal of each other. Cos theta and sec theta, they are reciprocal of each other, and the product of two reciprocal things is 1. But minus is also there. So minus 1 is the answer. 1 is not the answer. I hope that is clear. So this is, a good example of sign convention, application of sign convention. But you see, this does not work every time. There are something called allied angles as well, maybe allied angles. I don't know how to pronounce that exactly, allied angles, right? Allied angles means two angles whose sum is 90 or multiple of 90, right? So for example, if people ask something like this, sine, suppose sec I'm writing, no problem, sec 90 minus theta suppose, and suppose they ask sine 270 plus theta, something like this. 270 plus theta and something like this. These logics, if people ask, how will you find these values? See, so I'll explain it from very basic. Please concentrate properly. So for example, if somebody asks, can you tell me the value of sine 120, right? See, normally people remember values of standard angles like 0, 30, 45, 60 and 90. After that, you don't remember it. So you have got these concepts for that, right? So how will I do that? So first thing is you make that figure, right? Or the axis. You see, this is the x-axis and the y-axis and then the origin. And you remember this thing as well, ASTC. You put it over here, ASTC rule. Now, talk in terms of angle. If I start from here, this is basically, just understand like this, 0 degrees and 360 degrees. Because if you make one complete revolution, this will be 360 as well. Now what about this? This is 90 degrees. What about this? That is 180 degrees. And if you add one more 90, that will be 270 degrees. Like this. And obviously, if you make revolution more than 360, that also can happen. For example, this point is what? This is 360 plus 90 as well. 360 plus 90 is what? If you will do, that is 450. So this is 450 as well. And so on. If you keep on adding 90, this is what? 450 plus 90 is what? 540. So this is 540 as well. So like this you can think. If you add 90, this will be what? 630 as well. Am I right? Yes, 630 as well. And obviously, if you add 90, that will be 720 as well. In that manner, it keeps on going, right? I hope that logic is clear. Now, if somebody asks to find the value of this one, so write the angle around the vertical axis or the horizontal axis. By vertical axis and horizontal axis, I mean in terms of angle. So basically this can be written like this. You see 90 plus 30, right? You can write it like this, or you can also think of it like this, sine 180 minus 60 as well. Like this also you can think. So in both the ways you can think, you will still get the same answer. Okay. Now what is the first thing? First thing is the angle is 120 degrees. 120 is in which quadrant? You see 90 plus 30. It is in the second quadrant. So in the second quadrant, when the angle is in the second quadrant, then S for sine and its reciprocal cosec is positive and all other trigonometric ratios are negative. So the answer will be positive. Correct? Now, when the reference is vertical, these angles, sine will change to cos. And you'll put the same angle. Like they will change to co-functions. I'll write the co-functions. By now you already know sine, cos, they are co-functions. Sec, cosec, they are co-functions like this. Then tan, cot, they are co-functions. Right? Like this. So again I will say, when the reference is vertical, then sine will change to cos. Vertical means any out of these type of angles, sine will change to cos and cos will change to sine, sec to cosec, cosec to sec, tan to cot and cot to tan, right? And you know the cos 30 is sine 60 root 3 by 2. So the value is root 3 by 2. Now if you see the same thing over here, like this also you can think. So 180 is this minus 60, you're in the second quadrant. This angle is in the second quadrant. So when the angle is in the second quadrant, then S for sine and its reciprocal cosec is positive and all other trigonometric ratios are negative. So the answer will be positive. Now when the reference is horizontal axis means any angle like this. You see, just check it. Maybe I've done some mistake, but I don't think so. You can check it. So when the reference is along the horizontal axis, the trigonometric ratio will not change. So sine 60 is the answer. Sine 60 is what? Root 3 by 2. So are you seeing that we are getting the same answer? We must get the same answer. If you're not getting the same answer, you're doing some mistake. I hope this logic is clear. So I'll take some other example over here. For example, I take sec 210 degrees. Correct? Now what will I do? Again, I'm saying write the angle. Maybe you can do in your mind as well. I'm just explaining, therefore I'm writing everything. Write it around the angle around either the vertical axis or the horizontal axis. So if you have got 210 degrees over here, we can write it like this. One way is to write 270 minus 60, right? I hope that's clear. You can't say, sir, I will write 200 plus 10. You don't know the value of trigonometric ratios of 210. It's not that there is a method to find the trigonometric ratios for any angle. You won't be able to do that. You can only do that for standard angles, right? So you can write it like this. Now you see over here, the angle is 210. It means 180 plus 30. So the angle is in the third quadrant between 180 and 270. In the third quadrant, only T for tan and its reciprocal cot will be positive and all other trigonometric ratios will be negative. So sec, it will come out negative. The answer will be negative. And when the reference is the horizontal thing, vertical axis, when the reference is vertical axis, sec will change to what? Its co-function, cosec. So that will be cosec 60. Sine 60 is root 3 by 2. Cosec 60 will be what? 2 by root 3. So this is the answer. Now the same thing can be understood like this as well. You see, this is sec 180 plus 30 also I can write. So the very first thing you have to see that this angle is in which quadrant. So this angle is in the third quadrant, 180 plus 30. So when the angle is in the third quadrant, then using ASTC rule, T for tan and its reciprocal cot will be positive and all other trigonometric ratios will be negative, right? So sec will come out negative. So minus. Also, when the reference is horizontal, trigonometric ratio will not change. So sec will remain sec only. So sec 30. Sec 30 is reciprocal of cos 30. Cos 30 is equal to sine 60 root 3 by 2. So minus 2 by root 3 is the answer. So you see, that's how you remember it. I hope that logic is clear to every student in this session. So that's how you do for allied angles or allied angles. I don't know. You can pronounce it like that. I hope it's clear, guys. So that's the way of thinking in that case. Now, you see the angle can be more than 360 as well. It can be more than 450 as well. So you have to do the same logic. You just have to decide that it is in which quadrant. I hope you understand that. Let's do some questions on it. For example, we have to find the values of these things, right? Now, something you have to remember, if you have done earlier, you will obviously be able to think that, right? Like 360 and then 360 into 2 is what? 720. It means that 720 degrees means, see, you start like this and you make anti-clockwise direction rotation, right? So if you make one complete revolution, it is 360. If you make another revolution, it is 720 only. Means 720, you are on the starting point only. So basically, can I write it like this? Sine 720 plus 45. So basically, it is 720 and then plus 45. So you are in the first quadrant only. In the first quadrant, all the trigonometric ratios are positive. So the answer will be positive. And the reference is horizontal. You see 720 is this thing, right? 720. Like 0, 360, 720. When the reference is horizontal, trigonometric ratio will not change. Sine will remain sine only. Sine 45 is 1 by root 2. That's the answer. So like this you can think. Now what about negative angle? How will you think like that? See, if you go in the clockwise direction, that's positive angle. When you go in the anti-clockwise direction, that's negative angle. What's the big deal in that? It's not a big deal, right? Now you see 720 into 2 is what? 1440. Now you see over here, if you start with this and you go clockwise, this is minus 360, right? Again do like this, another 360, another 360, another 360. If you do 4 times, then this angle 4 times is minus 1440 because you are going in the clockwise direction. Now you see over here, this angle can be written like this, cosec minus 1440 plus 30 over here. I hope that's clear. So minus 1440, you're still over here. Now plus 30 means again anti-clockwise. So you're in the first quadrant only. So the answer will be positive only. When the angle is in the first quadrant, every trigonometric ratio will open out positive. And the reference is, horizontal. So trigonometric ratio will not change. So cosec 30 is the answer. Sine 30 is half, cosec 30 is 2. Reciprocal of it. Now when the angle is in terms of radian measurement, you remember radian measurement, right? That 2 pi radian is 360 degrees. 2 pi radian is equal to 360 degrees. That's the conversion. Like those are the 2 units of measurement. Like you have got degree Celsius, degree Fahrenheit and Kelvin for the measurement of temperature. In the same manner, in order to measure plane angles, you have got degree measurement and radian measurement. And that's the relation between them. 2 pi radian is 360 degrees. So from here you can think like this, that pi radian is 180 degrees. If you write only pi, it means they are talking about radian angle only. For example, if I write only sine 30, it means they are talking about 30 radian. Because when they mean degree measurement, they will put this. If nothing is mentioned, they are talking about radian measurement. So pi radian is 180, pi by 2 is 90, right? Pi by 6 is what? And so on. You can keep on thinking. That will be 30. Pi by 3 is 60 degrees, pi by 3 radian, pi by 4 is 45 degrees, and so on. You can keep on thinking like this, right? So you have to convert the angle like that. So 19 pi by 3. See, can I write it like this? 6 3s are 18, right? So can I write it like this? 6 pi plus pi by 3. Because that will be what? 6 3s are 18 plus 1. So 19 pi by 3. Now why we are doing 6 pi? See, 2 pi radian is 360 degrees. So 4 pi radian is what? 2 pi is 360. 4 pi is what? 720. And then 6 pi will be another 360, right? It means you are over here only. You see, if you start anti-clockwise like this is 2 pi, another 2 pi, another 2 pi. So that is 6 pi. Because 2 pi radian is 360 degrees. So you're starting from this point only. And plus pi by 3 means what? Plus 60, because pi by 3 is 60. So what will I say? It is in the first quadrant. So that will open positive only, because if the angle is in the first quadrant, every trigonometric ratio will be positive. I hope that's clear. And then the reference is horizontal, right? So same trigonometric ratio will come. So tan 60 is what? Root 3. That's the answer. Tan 60 is what? That is equal to root 3. Now this question I'm giving homework, guys. Try doing this thing and let me know the answer in the comment after the class. Try doing this. You have to find the value of this thing. The logic I had already explained, right? Now let's do another questions. For example, you see there is a proof to it as well. Some students will ask that why these logics are working. Some students will ask, sir, why it's happening that when it's any vertical like the axis like 90 and these angles, then the trigonometric ratios are changing to their, the other ratios like sine is changing to cos and so on. Why it's happening? You might ask that. So for this, I'll make another video, guys, a separate video for the proof of it. You might also ask, sir, if these are the angles like horizontal axis, then why the trigonometric ratio is not changing? There might be some logic for that, and there is a logic for that. I'll make a separate video for that, right? As of now, you just need to understand the application of it. So let's do one more question on it. For example, this one, A, B, C, D are angles of a cyclic quadrilateral. Then we have to find the values of these things. Now, a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary. So if there is any cyclic quadrilateral ABCD, opposite angles are supplementary. It means A plus C is 180 and B plus D is 180. So this thing can be written like this. You see, cos A can be written as it is, cos B can be written as it is. Now you see A plus C is 180. So in place of C, can I write 180 minus A? I can write 180 degrees minus A. In the same manner, B plus D is 180. So in place of D, can I write 180 minus B? Opposite angles of a cyclic quadrilateral are supplementary. Now you see this will remain as it is, cos A plus cos B. Now you see over here, I was explaining that thing over here. So we have to find the value of cos 180 minus theta. Now 180 minus theta is in which quadrant, guys? This is 180 minus theta. You are in the second quadrant. In the second quadrant, S for sine and its reciprocal cosec will be positive and all other trigonometric ratios will be negative. So the answer will be negative over here, right? Now when the reference is horizontal axis, trigonometric ratio will not change. So cos 180 minus theta is cos theta only, correct? So over here, this will be what? Minus cos A. And this will be what? Minus cos B. So you see, this will be cancelled out and this will be cancelled out. The answer is what? 0. Now let's do one more question on the basis of this, guys. For example, they are telling you to find the value of this expression. Same type of logic we have to use over here. You see, cot A you can let as it is. Now you can make this thing ASTC. ASTC. Now that is tan 180 plus A. 180 is this, guys, plus A. It means you are in the third quadrant. In the third quadrant, T for tan and its reciprocal cot is positive. All other trigonometric ratios will be negative. So that is plus only. That will be positive. And the reference is horizontal. So trigonometric ratio will not change. So that is tan A only. Now over here, 90 plus A. This is 90 plus A. You are in the second quadrant. 90 plus A is in the second quadrant. In the second quadrant, only S for sine and its reciprocal cosec will be positive and all other trigonometric ratios will be negative. So this will open up negative. Also, the reference is vertical. You see 90, 270. So this will change to its co-function. It will be minus cot A. Now over here, 360 minus A. So you see this is 0, 180, 270, 360. 360 minus A. You are in the fourth quadrant. In the fourth quadrant, C for cos and its reciprocal sec will be positive and all other trigonometric ratios will be negative. So that will be negative only. And when the reference is horizontal, that is 360, right? So same trigonometric ratio will be there. So minus tan A. So this is the expression. You see cot A and cot A will be cancelled out. Tan A and tan A will be cancelled out. 0 is the answer. So that is very important concept, guys, from any examination point of view, starting from grade 10, including Olympiads. And obviously after that, if you go to class 11 and you start preparing for IIT, JEE, or even your board exams, these things will be very much important. I'll make a separate video that why these things are actually working. That's all we needed to discuss over here, guys, on the Infinity Learn Class 9 and 10 YouTube channel. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever is discussed in live sessions, you can get their PDF as well. Bye-bye, guys. Take care, everybody.